Welcome to our video lectures on machine learning algorithm. We covered a number of algorithms in our previous videos. The first was the simple machine learning algorithm, that is the simple linear regression. The next video we have gone for the multiple linear regression. We will have a number of regression like this. Let us see what are the different type of machine learning algorithms are available. We have divided into three categories. One is the supervised machine learning, one is the unsupervised, and the third one is the reinforced machine learning algorithms. Under the supervised, we have regression, and under this regression we are having linear regression, and also this different type of other multiple linear regression, simple linear regression. Then we are having polynomial regression, we are having decision tree, we are having random forest, and also in addition to regression we are having some classifications, and again we are having a number of classification algorithms like k nearest neighbor, trees, logistic regressions, naive bayes, and also support vector machine. So these are the things coming under the supervised machine learning. And under the unsupervised learning, again we are having three types. One is the clustering. The clustering will be going for the SBD, PCA, principal component analysis, k-means, and under this association analysis we are having a priori and FP growth, and the last one is the hidden Markov model. Under the reinforcement learning, we will be going for this continuous and categorical. These are the two things we will be covering under these things. Now, let us go for, because the two algorithm already we covered, that is the simple machine learning, simple linear regression, and also the multiple linear regression. What happens actually, in case of simple learning, we map it into a straight line, just like that, just we map into the model, y is equal to mx c plus c or ax plus b, like that we go for that one. And whatever our data set, we try to map to that one, so that it becomes easier to predict the future. But whenever we are going for more than one independent variable versus one dependent variable, in that case it is difficult to go for this simple linear regression. So in that case we go for multiple linear regression, right? So what happens, sometimes you will see, see for example you see here, suppose the data points are here like this. You can see the points are here in the blue colors or the green color, whatever you say. And if you try to map to a simple linear model, what will happen? The model is here a straight line, but the points are far away from that one. So even if you go for to predict, so it will give you the wrong data, wrong output. So what we need to do? So we need to train or we need to design a model, what we call it the polynomial model. Okay, so in this polynomial model, you see it better fits all the data, better fits to this one, and here it will be more appropriate to predict. And you know the simple linear model, the equation is represented by y is equal to b0 plus b1x. Okay, y is the output in the we want to, that is the dependent variable, and b0 is the intercept in the y-axis, and b1, as you know this, and x is the whatever the data points will be taken there. But while we are going for this polynomial model, here it is something represented equation like that, y is equal to b0 plus b1x plus b2x1 square. So this polynomial means it can be of any degree. Here the highest degree is 2, so we can go for x cube, x, like that we can, because poly means many. So in this way we have to design a model, and we have to do for these things. Before that, let us see what are the different steps we will be following. First of all, we go for the data pre-processing steps. Then we will be going for the fitting a decision tree algorithm to the training set, then predicting the test results and the test accuracy result using the confusion matrix and visualization test, etc. the results. Okay, training and testing results. So here let us have some idea about what is this polynomial regression. This polynomial regression, it is used where data points are arranged in a nonlinear fashion, and we need the polynomial regression model for that purpose only. Okay, now as I told you that the polynomial regression equation is represented by this one, y is equal to b0 plus b1x plus b2x square plus b3x cube up to plus bnxn. So there is a nonlinear relationship between the linear, means it can be represented as a straight line, but you see the relation, it is just mapping just like a curve. So it is, we call it as a nonlinear relationship. So between the position levels and also the salary. Suppose we go for a data like the employee position and their salaries, and we need to predict the salary based on that data, right? And our goal is to build a bluffing detector regression model, so that HR can hire an honest candidate. That is the main goal. purpose of these things. Okay, so this is the things we want to do it here. For this, what we need to do, we go for representing it by a model. First of all, we'll be using this Jupyter Notebook, which is already installed in the Anaconda 3. And once you go for this Jupyter Notebook, here you can find already it is done, and I created a new one, and already I created something like that polynomial. You can see a number of things I implemented here. So you go for this random pulsar prediction polynomial IPYNB, right? Fine, yeah, fine. It was already there, so there is no need to open it here. So as I told you that the very first part that we go for, if you remember, that will be importing some of the libraries. What are the libraries you will be using? You will be using NumPy, and you will be using matplotlib, and also you will be using pandas, right? So what we do here, import pandas as pd, import NumPy as np, and import matplotlib dot pyplot as plt. So these are the minimum things you are going to so you can see it here. Just I put it here and shift enter, it will run, and we will go to the next cell. Then what we need to do, we go for importing the data set. You see here in the importing data set, first we should know what is the data set we are using. So we will be using position underscore salaries, the CSV file. Where you get it? So for this we need to go to the Kaggle. You can create a account there. That account you can link to your Google ID or whatever things are there, or you can create your own account there with your all credentials. There you access, just to type in the search the position underscore salary. So you will have, I think, some archive like that, it will come. Then you open that one and extract, you will have this position underscore salary.csv. Then what you need to do, once you unzip that one, then you in our home page, while you are running, for running all the things, what you do, just you click it here and type the Jupyter Notebook. When you type the Jupyter Notebook, so one interface it will come and it will run also, right? So it will come and it will run. So yeah, it will run. Then once it is running, then we will have this interface, that is the web pages, it will appear in front of you. And you want to create a new, you can create it here, or if you already created what I am showing you there, already I have shown it here. So then by default it will come some default name. So you have to click it here and give a name to that one. Okay, so this is then, okay, cancel this name as it is polynomial, I have given it here. Fine. Now up to this you have done. Then the libraries are installed. Then the data set, whatever you want to do, suppose you already downloaded and you put it there in the download folder or some folder, that you have to upload. What you do, just drag and drop it here in this home page, select.create, whatever the, and then it will be giving a things, just you want to upload, just click upload, it will be uploaded. So once it is uploaded, you can see the data, it is already available here. You can see position underscore salaries.csv, you can see it here, right? So in the same folder it is available, so you don't have any problem. Then for importing this data sets, what you do, I use this pd dot read underscore csv. This is a csv file. Suppose it is in excel file, xls, so in that case you can open it and convert to .csv file. I hope you all be knowing that one. Otherwise just you open it and save as other than the existing xls, so you go for the csv file, right? So once you finish this one, then the position underscore salaries.csv file will be available there. That drag and drop it here, so upload it here, it is over. Then what I do it here, then using this pd dot read underscore csv, this is the method I use to read that one. What is the file name? Position underscore salaries.csv. So this will be under single quotations, and that you store it as data set, data underscore set. Fine. Now onwards, whatever I will be using to access that data, I will be using data underscore set, right? Because that is in the 2 we have done it here, right? Then here I am writing defining what is x and y. So x is equal to data underscore set. So I am using this iloc. What is the meaning of that? I am adding one index here, 1, and I am including the last one also, because in the data set, if you see the data set, you will having minimum 0 1 0 1 2 like that, 3 will be there column. So we add one index there. So this meaning is that colon comma, so include 1, that is the index, and 2 including the last one also, it will come. Then why you put the data set only that 2, the last one. So if you remember the previously what you are doing, so we are dropping the last one, whatever we are going to predict. So then after dropping, we save it in some x underscore data or something like that. So that will be representing just the x, and what we drop, that we put it as the y. So then whatever the work you do it on this x and y, fine. Then what we do, then in the we decided everything on this, what is this x and what is this y. Shift enter, you run this program, because already run without wasting time, it is already done. Then coming to the fourth point, you see it here, we need to feed the linear regression to this data set, because we want to compare with this linear as well as the things. So how do we go for fitting into any regression? So we need to go for the sklearn, okay, scikit-learn. So by default it will be there with these things. From sklearn dot linear underscore model, here you need to import the linear regressions, okay. So I imported the linear regressions, then I saved it as lin underscore res linear regression, which is called linear regression method, or the thing that, and linear regressions fit xy, that what is the data x and y already you found in cell number 3, the same thing you fit. What is the method we are using? Dot fit method. So linear underscore regressions, because linear regressions we are getting from this linear regression, which is imported from this sklearn dot linear underscore model you are importing, right. Then the output will come, yes, in a Jupyter arrangement, this is already everything is there. Then what we need to do, again we need to, because this is what you have done, it is the linear model. So just for a comparison we have done it, but we actually go for this polynomial. Then what we need to do, the fitting the polynomial regressions to the data set also. Here again in your cell number 5, we see it here, from sklearn dot preprocessing import polynomial features, right. Then polynomial underscore regression, which is equal to polynomial features. Here degree we have given 2, you can put degree 2. Degree, what is the mean degree 2 means? Ax b1x plus b2 x square, like this. So then you can write b0 plus b1x plus bx square plus bx cube. Suppose degree is equal to 3, then it will come up to x cube. Degree is equal to 4, it will come up to x4. You can take all the things, just you change the degree, because I want a binary here of degree 2, that's why I am putting a degree is equal to 2, right. Here you can see the line number 3 in cell 1 2 3, right. Then I put x polynomial, what is this? The polynomial underscore is fit transform x. So I am using this fit underscore transform x, whatever the x I put it here, that I fit it here. Then the linear regression underscore 2, which is equal to this linear regression, because the previous one I used for this simple linear, I am using the polynomial. Then I am again going for the fit the x polynomial underscore y, right. X polynomial here already I calculated using this transfer method, get it now. So if you are having any doubt, you can go to the sklearn. In the sklearn you can see the tutorials or the documents of sklearn, there how to fit to the linear regression, how to fit the polynomial regressions, all the things will be there, just you can use that one here, okay. So what I have done it here, for linear regressions I have already done there, and for the polynomial regression only regressions I am only degree is equal to 2 here. You want to degree 3, degree 4, you can do it, that is no problem, okay. Then again I am repeating, from sklearn dot preprocessing import polynomial features, that is the first one. Then polynomial regressions is equal to this polynomial features, and the parameter I am giving degree is equal to 2, right. Then what I am doing, this polynomial regression dot fit underscore transform of this x, that you save it as x underscore polynomial, right. Then linear regression to you put it this one, and linear regression dot fit of x underscore poly, what we calculated, and y. Then it will map to all the things here. Then we are going for this plotting of all things. For plotting, what you do, so I told you that we will be using this matplotlib, and matplotlib already if you see in the top, I already imported import matplotlib dot byplot as plt. So now onwards this matplotlib will be using plt, right. Then what I have done here, plt dot scatter x comma y and color is equal to blue, I am putting the parameter. That means the x and I have already calculated, that you plot, and the type is equal to scatter, right. So plt dot scatter, so it will be coming like this 1 2 3 4, like that it will come actually. This red line it will not there, because that is another part. Then plt dot plot x, the linear regression, predict x, and color is equal to red. Then the linear regressions I am mapping, putting all the things of linear regression, which is represented by the red line. So up to this you can see it here, this is the blob detections model, it is for linear regression, it is clearly given. So same thing I am writing, the title is blob detections using this linear regression. Then label is equal to position levels, and y label, x label is equal to position levels. You can see it here, x label is equal to position levels, and y label it is the salary, right. then plot dot show, it has come. Now what you need to do, we go to the visualization result for its polynomial regression, because the linear regression, the drawback is that you can see the scattered plots are here, someone is here, someone is here, someone is here, so it is not fitting to this linear line, right? So for that, what you need to do, we have to plot it with a polynomial regression. Then what you have done it here, so plot scatter x comma y, color is got blue, so these points are already scattered here, scattered for the scatter point. Then plot plt dot plot x comma linear regression to all the things that I have done it here. Then this is not linear regression, this is the polynomial regression, because you remember linear regression to what you are doing it here, that is for the polynomial regression. Okay, underscore, this is the polynomial regression, so linear regression underscore 2, but linear regression is represented as linear underscore regression here, that is the linear regression, because already you downloaded, I already put it here, so this is already done as the linear regression underscore 2, that is for this polynomial regression, right? Remember that one, right? So then with that one, whenever we try to plot it here, then you put the title is something with the polynomial regression, then x label is the position levels and y label is the salary, and plot show. Then you can see it is mapping to this one, and this is, it is run for degree 2. Suppose you want degree 3, then there itself you change the degree is equal to 3 or degree is equal to 4, whatever things you want, put it there. Then while you go for this linear prediction, suppose I want to predict the salary for this something like that, in that case linear prediction and linear regression dot predict for this value, and where it will print this linear predictions, it is showing it is something like that, some 3,30,000, that like some value it is showing. Okay, then polynomial underscore predict, again we can go for that one, that is the thing also it is coming. Then you can see where you get this data set, you can say that because I have not seen the data, so you can go for here, just you click it here and just type b, sorry, back, click it here and put it b, it will create another line here. So if you go for this print print and you put it here, what is the data set, suppose the same data set I want to, you can put it here, otherwise there are n number of ways you can show the head, data set dot head, like that also you can do. Okay, like that. Okay, print okay, that you can do also there, that is not issue. So there you can see the data set for the first some lines also you can see there using that one. From that we have taken one and we are going for the prediction of that one, which is coming like this, right? So I hope you got the minimum knowledge about this polynomial regression, and as I already explained you that this polynomial regression, this is coming under this supervised learning, and we have completed the first one is the simple linear regression, then is the multiple linear regression, and in this video we covered the polynomial regression. So thank you for watching this video. If you do like this video, please share with your friends and also don't forget to subscribe. Thank you for watching this video.